let us learn about gravastars. Let's learn.
There might be an object so indestructible, extreme, and brutal that it could kill black holes. Gravastars. Cosmic soap bubbles filled with pure energy and with a shell made of the weirdest material that's possible in nature. What are they? What do they look like? And are they just a theoretical fever dream, or will they change our understanding of the universe forever? The birth of the most extreme objects in the universe. Very massive stars die in the most dramatic way possible, a supernova. Yes. We've explained this process in detail before, but
yeah, I learned actually that so like the stars that we see in the sky, some of them could actually be dead already, but because it takes so long for the light to like travel or something, we still see it. And I was like, huh? What? That's... yeah, that makes my brain hurt. Yeah, I was like, what? What do you mean? Actually, I think Jello told me that. I was like, what? I think I watched a video from these guys about the dark forest theory. Oh, what is that? Now I have to look that up. Hold on, I have to look that up. Dark forest theory. Just so I don't forget, so that we can watch it later. Okay. Okay. Thinking about how light travels in space makes my brain hurt, but I love it. Yeah. This example that I gave of the fact that, like, the stars we're seeing right now might already be dead, that I can wrap my head around, but then there's, like, other things that people talk to me about space, and I'm just sitting there like, huh? What? Okay, sure, yeah, that sounds cool. Because they are really far away and light only travels at the speed of 300,000 kilometers per hour. Yeah, yep. Yep, so it could take like a couple of years for us to actually see a star disappear. Even though like the star's already gone, it could still take years for us to see it be gone. I remember a couple years back in the night sky, a star died out, but tracing it actually died when dinosaurs still roamed the earth. Wow! Damn. Some of the brightest stars may have died so long ago that one day we're just going to be cruising down the road and the sky is going to flash bang us. I was this just reminded me, I was driving Jello to work one night? Yeah. Or was it like in the day? I don't know. It was dark outside. That's all I remember. And we seen or like as I was driving like in the sky, I seen all these particles all of a sudden like shoot across the sky, and I was like, oh, whoa, what the hell was that? I think I learned later though that it was actually some kind of orbiting machine or something that came into the Earth's atmosphere and like shattered or something. But it was still pretty cool to have seen. And scary. A couple of years, Hoshi. Try tens of thousands of years before the star death is seen here. Wow. Yeah, I mean, I guess if we're talking about it having died in the dinosaur era, then yeah. Yeah, true. Okay, back to the video.
But in a nutshell, in less than a second, their cores collapse, crushed under their extreme gravity. The star's shell rushes in, bounces against the collapsing core, and explodes, boom, shining brighter than whole galaxies. Depending on how massive the star was, there are two possible outcomes. Either the core compresses into a super-dense neutron star, or it kind of breaks reality and collapses into a singularity, an infinitely dense point with no size or dimensions at all. A place where the laws of the universe stop making sense and time and space are reversed. A black hole. Gravastars are a third, even weirder option.
What?
Instead of collapsing into an infinitely dense point, the core is kind of ground down, like a rock pulverized to dust by a cosmic hydraulic press. Atoms and particles are crushed so hard that they transform into pure energy. A sort of mini-universe, if you want. And just like our universe, this bubble violently wants to expand and grow. In a fraction of a second, the bubble smashes into the collapsing star around it. The unspeakable mass of the star collapsing under its own gravity meets the titanic violence of the expanding energy bubble. Like an ancient god hammering on its anvil, matter is trapped between an immovable object and an unstoppable force, forging a new kind of material that we've never seen before, but that we know is physically possible. And then it suddenly stops. A gravastar is born. What does it look like? Cosmic soap bubbles. Just like black holes, a gravastar can have any mass, but a typical one would be about the size of the London metropolitan area and as massive as 10 suns. The shell of the gravastar is utterly dark and the coldest thing in the universe, only a billionth of a degree above absolute zero. If we look at it in deep infrared, even the cosmic microwave background glows bright in comparison. How can anything made of matter be that cold? Don't all atoms jiggle back and forth? The thing is, the shell's not made out of atoms. It's made from an entirely new, unique and extreme matter that doesn't have a name yet, and that's at the very limit of what's physically possible in nature.
Galactic flubber. It's galactic flubber.
Actually, the shell is so incredibly thin that atoms seem truly gigantic next to it. And yet, despite being ultra-thin, because it's been forged by two impossibly extreme forces, the shell is incredibly tight. So tight that if you wanted to stretch the whole shell by just 1 meter, you'd need the energy of an entire supernova. What about the inside? Well, it only gets weirder.
Oh my god,
the interior of a gravastar is perfectly simple because it's sort of empty. Completely empty. A perfect vacuum without a single atom, particle, or wave. But despite being as empty as it gets, this vacuum is boiling with the most primitive and fundamental kind of energy in the universe. We need a detour to explain how any of this makes sense. The fundamental nothingness at the core of it all. The inside of a gravastar breaks our brains a bit because it's a sort of super-condensed nothingness. What does this even mean? We'll have to simplify and use metaphors to make sense of what scientists measure and calculate. According to our current understanding of physics, particles like quarks, electrons, photons, and so on are not really solid objects, but sort of waves in an ocean. In our human world, you can't have waves without water, and in the smallest world, you also can't have particle waves without some kind of underlying, omnipresent cosmic fluid. This fluid is the vacuum, what we perceive as nothingness. It's the fundamental ocean at the bottom of reality.
Quarks are smaller than atoms? Oh. What the heck? I never heard of quarks when I was in school. Or I didn't remember, maybe.
The waves of this vacuum ocean are the particles that make up you and everything else. But even when there are no waves or particles traveling through it, the fluid is still there. And like any fluid we know, it has inherent energy. Vacuum fluid is everywhere in the universe. The room you're in is 99.98% vacuum between the air particles bouncing around. Between the trillions of particles making up your cells, there's vacuum. But it's different inside a gravastar. When our star collapsed and condensed so violently, it was as if the universe took a cosmic pump and compressed as much vacuum fluid as physics allows into a kind of super dense nothingness. As said before, even without any waves,
so this sounds like if you were to take a balloon and like blow up the balloon to the point where it would burst, but it just doesn't burst. Am I right? Am Am I understanding it correctly? Imagine a balloon you blow up, but it doesn't have the air you use to blow it up, but keeps its shape. Oh. Okay. That sounds crazy.
Nothingness vacuum ocean of the universe has energy. But the superdense vacuum inside a gravastar has almost a billion, trillion times more energy per cubic centimeter
What number is
than
that?
the vacuum outside the star. This is an unbelievable amount of energy and mass in a tiny space, just like, you may have guessed it, black holes. This intensely compressed vacuum ocean can't be compressed any further. It's at the absolute physical limit of anything that can be squeezed together without breaking physics, like black holes do. The ocean would love to stop being so tight. It wants to stretch out and flow back into the ocean that surrounds the star, but it's trapped in the safest prison possible. The shell, which itself is right at the edge of the physical limit of any material possible. An eternal stalemate between two limits of the universe. Let's leave this world of metaphors and get back to our world that feels more real. In our world, gravastars are perfectly black, eternal objects with borderline insane amounts of mass. Because they're so cold, dark, and massive, from the outside, gravastars look and behave exactly like black holes. Both massively curve space around them and create all the fun effects we love black holes for, from trapping mass and light in accretion disks or slowing down time as you get closer. For details, we've made 1 or 2 videos on black holes before. If you fell into a gravastar, you'd be extremely dead before you even hit the surface, ripped apart and ground down by the gravitational forces. And once your scattered remains touch the shell, the atoms you were once made of would probably break down and dissolve completely, only to be converted into the vacuum energy of the interior, making the gravastar an infinitesimal bit bigger and an infinitesimal bit more massive. Okay, this was fun and all, but what exactly is the point? Isn't this just another video of wild scientific speculation just for the sake of it? The point. Black holes were suggested more than a century ago as an abstract solution to equations of gravity. For more than 50 years, they were considered mathematically valid, but too absurd to be real. Few believed they actually existed. But scientists kept working on paper and looking at weird things, and then we saw stars being thrown around by invisible titans. We saw light stretching around invisible gaps in the sky. And as our technology and theories improved...
Oh, wait, so black holes were also just a theory? But then they actually found some. I don't think I knew that. Oh, I mean, I guess, though, to be fair, I guess a lot of this stuff would have just been theory and then proven. Damn. Okay. Ooh, we should watch the black hole soon, too. We should, watch the black hole ones. If the shell can't expand, how does it get bigger when it absorbs matter? It doesn't. It's just all... it's just all extremely pressurized inside the gravastar, apparently. So, yeah, the gravagrator. The grava blender.
We even sort of took a picture of them. We have evidence for them, and they fit our theories. And nowadays, it's kind of common sense to accept them as real. Black holes are extremely elegant and fascinating, but they also created a lot of questions that have traumatized physicists for decades. Singularities literally break our best understanding of physics. They seem to delete information, which shouldn't be possible. Gravastars are a relatively new idea without any of those problems. They don't need singularities that break physics or delete information. They solve the puzzles of black holes, but they too create new problems, like weird exotic matter for their incredibly cold and tight shell, super dense nothing to make a supermassive empty core. But just like black holes, they do work on paper and fit what we see in the sky. So, are they real, and will we ever know? Actually, there is a way to find out. Black holes have an event horizon, while gravastars have a physical shell made of matter, which means that they behave very differently when they smash into each other. The collision of two objects as massive as they are creates huge amounts of gravitational waves, ripples in space-time that travel at the speed of light. You can think of them as the music of cosmic cataclysms. The collision of two black holes should sound like a bass drum, a deep thump that stops quickly. The two gravastars colliding should sound like a gong, leaving subtle echoes behind. Scientists are listening for these echoes in the music of the cosmos. Unfortunately, black holes and gravastars are surrounded by such strong gravity that it swamps most of the music. It's like trying to tell two instruments apart through a thick wall of concrete. You need very sharp technology for that. While we've made incredible progress in the last few years, we're not quite there yet. So this is where we'll end this story. Gravastars have the potential to answer some of the biggest problems in physics. Or they're just another idea for our discard pile. But this is why we do science. To learn that everything is different to the way we thought it is. Until the day we truly understand the nature of reality.
Damn.
Discovery is an ongoing process. What you know today might be proven wrong tomorrow. To evolve your worldview, you have to keep learning. And
This
our
is
partner,
an
Brilliant,
ad.
makes it easy to learn something new every day. Brilliant is designed to make you a better thinker and problem solver, with thousands of interactive, bite-sized lessons on just about anything you may be curious about. From maths and science to data analysis, programming, even the physics of black holes. In fact, we've partnered with Brilliant on a series of courses to expand your understanding of our universe. Each one is like a one-on-one version of a Kurzgesagt video that dives deeper into the topics of some of our most popular videos like rapids, supernova, and, you guessed it, black holes. You'll get hands-on with an interactive model of a black hole to see how its mass affects its surroundings. You'll also experience what it's like to be an astronaut floating dangerously close to one of these celestial behemoths. Brilliant has a huge library of other lessons to explore, with new lessons added each month. And you can get started whenever, wherever, right from whatever device you'd like. Spending just a few minutes learning on Brilliant each day helps you see the world in new ways, build powerful problem-solving skills, and end every day a little smarter. To get hands-on with Kurzgesagt lessons and explore everything Brilliant has to offer, start your free 30-day trial by signing up at brilliant.org/nutshell. There's even an extra perk for Kurzgesagt viewers. Anyone signing up through our link will get 20% off an annual membership once their trial ends. Welcome to the Kurzgesagt lab. Let's conduct a few stellar experiments. We'll first add some more mass to this protostar. More. A bit more. Wow, we've just created a blue giant, a star with 10 times the mass of our sun. Let's now add a couple of million years and see what happens. A supernova. Breathtaking. And look, it leaves behind a black hole.
It has uwu level.
Fascinating stuff.
It's uwu level 9000.
Be careful to preserve the sparkle. It's now time for Duck's final inspection. This one is always a nail-biter. He has incredibly high standards. Luckily for us, our work is scientifically accurate, offers an overview of important astrophysical processes,
it's uwu
and
level
stunner.
9. It's
Duck approves.
It's uwu
Looks like it's
9000.
ready to be shared with the world as a poster. A very special piece of Kurzgesagt.
I do love like all the art and graphics
You
in
can
this.
get this very special poster along with many other sciencey and spacey things created with love and care from our shop.
Okay, this is pretty
Every
cool merch,
Kurzgesagt
not gonna
product
lie.
you buy directly funds another moment we get to spend working on our videos. Thank you so much for being a part of our story and for making this channel
That was
possible.
some pretty cool merch. That was pretty cool. I love how we know everything about these terrifying objects in space, yet we know next to nothing about the ocean. True. Though I guess one is a bit more easier than the other, because like when it comes to the ocean, you reach a certain depth and everything just gets crushed. We have to just search for the light to reach us as the sound would dissipate in the vacuum of space. Yeah, pretty much. Pretty much. That's pretty cool though. Like if they turned out to be real, that would be pretty cool. Either way, both are dangerous. Yes, yes. This guy just likes saying black holes. It was said quite a lot. We know aliens live there now. Space is for some reason less scarier than the depths. I don't know. I feel like for me, they're both just as equally scary. Like when I actually sit there and think about the fact that I'm this tiny little speck on a globe that's literally just floating in space. just it's creepy. It's freaky. It's like freaky. Like I feel space is easier to explore as we can trace large events with the distance of light as how long it took the light to reach us, but with the ocean you'll get crushed by the weight of the ocean. Yeah. The ocean is scary because one day the fish will grow legs and invade us. Like that's us. like that's us. We're on this thing and it's just floating in nothingness. That's scary to me. Scary to me. Oh, yeah. Shit. I just doxed all of us. Whoop. Well, we all know where the Fluffles live now. I see my house. Yeah, I know. I see mine too. Like, holy shit. I didn't mean to dox us all like this. No. Really puts into perspective how much in the grand scheme of things we don't really matter. No, don't cancel me. I didn't mean to dox us. I'm sorry. I'm sorry. Yeah, we're just little specks. We're just tiny little specks on this round globe.